Hello and welcome everybody. This is your host DJ Stokes, aka Mr. Stokes. For those of you students out there, um, this video is for you. So welcome from Mr. Stokes. But let's get down to business. Our objective for today is to describe and simplify these things we're calling complex fractions. And just as a quick reminder, we just talked about rational expressions and operations on rational expressions. This is really the same concept in a different form. So let's just get started by taking a few notes. A complex fraction, okay, so a complex fraction is a fraction that has a fraction in its numerator or denominator or both. Now, I know that's a lot of talk about fractions, but this is simply that. It's a fraction composed of fractions, okay? What does that mean? Well, it always helps to take a look at a few examples. So here are three examples, okay? Now, is number one, a complex fraction? I say yes it is. And you might say, why? Okay. Well, I say number one is a complex fraction by this definition because in the numerator of this fraction, we have a fraction, 3/5, and in the denominator of this fraction, we also have a fraction, 8/25, which means that number one has a fraction in its numerator. It also has a fraction in its denominator, so number one has a fraction in both the numerator and denominator. So this is a number one, and that counts for both. Okay, category both is number one. Now let's look at number two. Well, x plus 1 divided by x plus 2 is a fraction. We know that from the previous unit. In fact, that's a rational expression to the quotient of two polynomials. And then this is being divided by the quotient of two polynomials. So this is a fraction divided by a fraction. So number two, I say, is also a complex fraction. You say why? And I say, well, it's the same thing as number one. It has a fraction as a numerator and denominator, so therefore it is a complex fraction. Now we look at the last one. Our denominator is not a fraction. This is just an expression with two terms. But in the numerator, we have ourselves a fraction. Now x over 2 minus 1 can have a common denominator of 2. So the numerator is in fact a fraction. And it's being divided by this expression, which still makes it a complex fraction, different from 1 and 2 because it doesn't have both, but it does have a fraction in its numerator. So number 3 here, sorry, just ignore that line. Number 3 is this thing. It has a fraction in its numerator, therefore it's a complex fraction. Example 1. Okay, so for example 1, our goal is to simplify this complex fraction. And that is a good goal to have because we are given all we need, which is a complex fraction. So our goal is to simplify. All right. And we are going to take a look at this thing, and it looks kind of complex, which, is maybe why they call it a complex fraction. But that's beside the point. We can still simplify it, but let's help ourselves by rewriting it to look like something much more familiar. In fact, it'll look like something that we just dealt with in the last lesson. Okay, so I can say that this complex fraction is the same thing as if I were to rewrite the numerator for z cubed over 3z quantity, so in parentheses, squared, okay, divided by, okay, and I'm going to use this symbol instead of that fraction bar, okay, which is equivalent, and then to z quantity in parentheses squared divided by 6z cubed. 6z cubed. All right, now this looks pretty familiar. We just saw this in our last lesson. This is just the division of two rational expression. So we can handle this. And we know when we see our division sign, we just simply rewrite the first term, okay, 4z cubed divided by 3z quantity. Have to include my parentheses. I can't forget to take those with me. That's important. And we'll see why when we go to simplify. And times, and then I invert or take the reciprocal of the second fraction, which is going to be 6z cubed divided by 2z quantity, don't forget your parentheses, those are important, squared. Okay. Now I can simplify. This is all multiplication across the top. This is 4z cubed times 6z cubed. Okay, so this is equal to 4, and I'm going to use the commutative property of multiplication that says I can rearrange or switch the order, rearrange the numbers and variables that I multiply. So I can do 4 times 6 times z cubed times z cubed. Okay, that's the commutative property of multiplication. And this is all being divided by, and here we have 3z quantity squared times 2z quantity squared. Now, because we have parentheses here, that means this exponent 2 applies to the 3 and the z. Okay, so the exponent distributes over the multiplication. Now, I'm just going to go ahead and square the 3. Okay, so that's going to give me 9. Okay, and then z squared. All right, just so I see that. And now this 2 squares this whole quantity. So again, the 2 squares the 2, which is going to be 4. Okay, and then I have another z squared. Okay, z squared. All right. Now, again, with the denominator, I can do as I did at the top, which I'm just going to rewrite really quick. 4 times 6z cubed, z cubed. So I have z cubed squared divided by, and then I'm just going to put my numbers first, 9 times 4. Okay, took care of those. Z squared, z squared. Okay, z squared, that's a 2, z squared. Okay, now I am almost done. We see now that we have some things that are going to cancel. Okay, so on the top we have a 4 and a 4. They cancel because 4 over 4 is 1, and 1 times everything else is just everything else. So they're gone. All right, now I'm left with a 6 and a 9. Okay, and I know 6 and 9 are both divisible by 3. Okay, so if I factor out a 3 from the top and the bottom and cancel them, I will be left with 2, and then I will be left with, in the denominator, a 3. Okay, and that takes care of my 6 and my 9. My 3's canceled. Now I have here z to the third times z to the third. So that's z times z times z times z times z times z. So I have 6 z's on the top. That is the same thing as z to the 3 plus 3, z to the 6th. Okay, in the bottom I have z squared times z squared. That's the same thing as z times z times z times z, or 4 z's, z to the 2 plus 2, or z to the 4th. So I know that I will have 4 z's in the denominator, 6 z's in the numerator, and so 4 of them will cancel, and I'll be left with 2 z's on the top. So I'm just going to rewrite z, and then I'll have another z, which is the same thing as z squared. And that is almost our final answer. Okay, we have to consider, what can't z be? We lost the z in our denominator, and we know that we can't have a denominator equal to 0 because our calculator gets really... Okay, example 2 of 2. We're just about ready to launch and try these on our own. Let's just go through this last example. Here we are given a complex fraction. Our goal, again, is to simplify. So we want to simplify this complex fraction. So the first step that we want to do and get used to is to rewrite this as just division of two rational expressions. Okay, so we have x divided by 2 minus 1. I'm not going to leave it like that. This is my numerator, so I need to group it. So I know that this is one thing, okay? And then this is being divided by our denominator, x minus 2, which is also its own thing, okay? So now that I have this set up, I know that when I divide, it's the same thing as multiplying by the reciprocal, okay? So I'm going to rewrite this again, and I'm going to give x over 2 minus 1 a common denominator of 2. Okay, that will be the least common denominator of x over 2 and negative 1. Okay, so the least common denominator is going to be 2, so that means I have x minus 2 over 2. Okay, and let's see, why is that? Well, because x over 2 is the same thing as x over 2, and then negative 2 over 2 is the same thing as minus 1. So that works. And now we're going to multiply this by the reciprocal of x minus 2, which is 1 over x minus 2. Okay. And once we do that, we can see that this is going to turn out working pretty nicely. Okay. So we can already probably see what we can cancel, but let's just write out all the steps. So if I multiply x minus 2 times 1, I'm just left with x minus 2 on the top. And then if I multiply across the denominator, I have 2 times x minus 2. So that's 2x times x minus 2. Okay. And then I see that x minus 2 on the top is going to cancel with x minus 2 on the bottom. And then I'm just going to be left with 1 half. Now, almost done, but we need to just consider that we lost this factor of x minus 2. And no division by 0, so we say we're not going to let x be positive 2.